Looking at our teardrop shape, I think this is like a pretty clever design, as we've discussed, in that the steps, are designed to match the ideal height of the user relative to the height of the stove. So yeah, we're looking at sort of the components that prize this sauna shape. And I think there's some benefits, there's some pros and cons to this one in terms of logistically how we're going to print it, how we're thinking about printing it, and then how we're thinking about assembling it. We would end up printing this one on its side, like we've discussed. And here are the inner and outer shells combined into one continuous print path. It's about 7.5 feet tall. And then in red over here, you see the side panels. These would be sit panels that would create the enclosure. Little model of the dimension of the stove, and then over here we see an initial design for what would be some steel legs that would hold up the taller side of the shape. I think the biggest issue with this one is that after we print it, we would have to tip it upright, and we can kind of simulate that here with the model, in that we would have to find a way to rotate this 90 degrees into its final shape at the facility, and do that very carefully, do that in a controlled way. This would be its final sort of resting position. Those are sort of, yeah, my initial thoughts. Like, yes, the shape is ideal. It just requires some logistics.
Hey, Fernando, like, do you have a sense for how much that thing's gonna weigh?
Approximately 5,100 pounds at a 1 inch or 25 to 30 millimeter bead width.
And does Rhino give you the ability to find the center of mass? It's going to be a heck of a lot easier to tip the thing if we can lift it at its center of mass and then have an operator with straps on either side sort of stabilizing it and executing the flip.
I don't have that capability, no. I think maybe there's a plug-in, but just based on like the using this miniature 3D prints, it gives you a good sense of like, yeah, how does this thing want to sort of tip and move? The bulk of the weight ends up being not necessarily centered, but slightly justified to the left. All of this weight potentially, yeah, something we could calculate.
To give it a little more resilience to the flip, would you imagine we would fill this thing with that insulated material, the foamcrete, as it were, while it's still upright like this?
Yeah, I think that would make sense. The other thought would be to split this in half. If we were to split it in half, forces us to do two flips, but half the weight. We would print it, we would fill it with our foamcrete. I think within that foamcrete, we would put some kind of rebar, threaded rod, and then these would just sandwich together. And, we would then put the sit panels on the ends as sort of end caps. And yeah.
Mm-hmm. Or possibly conduit for threaded rod?
Sure, yeah, our conduit as a sleeve for then threaded rod. What was that, Evelyn?
The most similar print that we have experience with to this would be the boulder, right?
Yeah, that boulder we did
a couple of years ago. Is there anything that we learned from that print that we're going to try to apply to this one as we're thinking about printing it?
Yeah, we learned a lot doing that print. I think that print was much more irregular in shape. So I think it was a little bit more difficult to find the center of gravity, to like lift it evenly. I think this one is going to be a lot simpler.
Mm-hmm.
But I think
that one broke at the top, didn't it? At the top curve. And we talked about reinforcing it differently. So I'm wondering about reinforcing this one.
Yeah, I think that foamcrete is going to be absolutely necessary to fill this cavity. We'll probably do some FRP along the length throughout the print. So yeah, I feel confident that like it'll be self-supporting, unlike that boulder shape was. That boulder shape was very irregular in this sort of direction, like it undulated. This has a nice clean arc, so we can cleanly put rebar where we need it. Not a huge concern in terms of it becoming self-supporting. I think it's just getting them upright.
Of course,
So-
what's kind of nice about this shape is that in the wild already, there are examples of 3D printed structures whose roof gets formed by tilting the structure up, and we have yet to showcase that. So that would be fun to show.
That'd be great to experiment with. And we get a lot of questions about that. People are really curious about being able to 3D print a roof, and we always use this tilt up as an example.
Yeah, it's a much more sort of efficient use of the material in that, you know, the 3D mortar is the most expensive part, and this sort of takes advantage of that. And I think if you look at just the number of components to sort of get this enclosed, like here we see the shell, the SIP panel walls, and that's really it. Obviously our door and window, but many fewer components to encapsulate this structure.
Was it this design, or was it a different design that we talked about having the side underneath support be storage for like wood for the wood burning stove?
I think all of them could have a little bit of storage, whether inside or outside of them. But yeah, this one I think kind of lends itself nicely. You know, this custom fabricated steel armature. You could imagine you're putting, you know, cut wood on these rails and stacking it up. You get some protection from the elements, you know, if your wood's sitting outside for a while. You know, this could be iterated on in terms of just straight legs versus this V shape. So, yeah.
Yeah, that's sweet.
Multi-use there.
I'm seeing this for the first time, but it also dawns on me that if it were possible and it made it structurally sound, these end caps don't have to follow the stair stepping. And if they came all the way to the ground, then they are themselves legs for the thing. The only thing that needed to be decubed, removed void of cubic volume is the interior itself. So the end caps could also be the legs, is a shorter way of saying that.
They could be, yeah.
Although we've talked about before that stair step shape, we've seen 3D prints before be put with the landscape of like a hill or like mountainous area or rocky. So the stair step shape we've talked about, that allows for that kind of installation.
Oh, I'm not saying we shouldn't do that shape. I was just saying for the legs. But it's true also that it looks funky, more funky shaped if you go ahead and have it like we have it here.
Yeah, I can see what you're saying. Just the SIP panel comes down.
And we've talked about how we're gonna clad the side paneling, so if it was something really interesting to look at, then I don't think we'd mind looking at more of it. You know what I mean? If we extend it down.
Yeah, I'm guessing it's still going to be a funky shape, so I guess that could be a possibility.
Yeah, the only, I guess, concern there then is, you know, these SIP panels aren't really acting as weight bearing. They're really just, you know, for insulation and cladding. Then we would want to, find a way to really secure the shell to the panels so that they carry the load.
But we were going to have that sort of threaded rod go all the way through the end panel, yeah?
Not necessarily, no.
We hadn't gotten there yet with this one, did we?
I don't think we need to. The threaded rod would just go through the shell, and then we would mask the ends of those with the SIP panel. No need for them to come all the way out, because then we have to fur this out to do whatever we want for cladding. Something to consider.
On this one, it's kind of nice, I think, that the stovepipe goes through the 3D printed wall with the foamcrete in it. Because that is a high heat area, and you otherwise have to box that out. You might still have to box it out, but I know if it's going through wood, you end up having to use yet another hardware fixture thing that stovepipe has to go through.
I think we would.
It is seeming like this is a really simple structure, which is also something valuable to be showcasing.
Yeah, and I think we'd want to justify the stovepipe to one side so that it's not, if we're printing this in halves, it's not right at the seam, essentially. It creates
It's also less in the way then.
Right.
Yep.
For the people in there.
away from, we'd want to put it opposite the door, so like, you're not running into it trying to come in and out of the door.
What's the overall length, or at least the overall length of the print?
7.5 feet.
7.5. Okay, great, awesome. So you can for sure lay down in it, which is nice. 2 people, even 2 tall people.
2 7.5 foot people could. Yep.
That's pretty tall.
Which also means that half of that is probably about the same size as some of those really small two-person saunas.
We could make 2 for the price of 1.
Okay, what else you got?